Welcome to the Explainer. Today, we're going to unravel a secret. A secret about the materials that literally make up our world. We're talking everything from the clothes on your back to the plastic bottle in your hand.
Okay, so let's just start with a really simple question. You've all noticed this, right? I mean, how can a plastic bag be so weak and flimsy, but a rubber band is super stretchy and strong? They're both just stuff. What is going on here?
Believe it or not, the answer isn't some crazy complicated thing. It actually boils down to just one powerful concept. It's all because of a giant molecule called a polymer. Okay, so let's get into it. What is a polymer? We're going to break down these massive molecules and see what they're really made of.
The easiest way to think about it is like this. A polymer is basically a long necklace, right? It's one single big thing that you make by linking a bunch of smaller pieces together in a chain.
So, if the polymer is the whole necklace, what are the little bits you build it from? Well, that's the monomer. The monomer is the individual bead. You know, that one small repeating unit that you just string together again and again and again. And here's where it gets cool. You can build these chains in a couple of ways. Sometimes you're making a simple string of pearls. All the monomers are exactly the same. But other times, it's more like a colorful, patterned necklace. You're using different kinds of monomers all linked together. And that variety is how we get so many different kinds of materials. So this brings us right back to where we started. If a plastic bag and a rubber band are both made of these polymer chains, why on earth are they so different? And here it is, the big secret. It all comes down to the bead. It's all about the monomer. The type of monomer you start with is what decides everything about the final polymer. You change the monomer, you change the material. It's that simple. And this is where the transformation is just wild. When you link these tiny little monomers together, the properties of the final thing can be completely radically different. I mean, you can turn a gas into a solid. You can take something that dissolves in water and make it totally waterproof. It's like magic. Okay, let's actually look at the numbers here because this is pretty mind-blowing. So you start with ethene. It's a gas. Its melting point is like minus 169 degrees Celsius. It's incredibly cold. But you link a bunch of ethene molecules together, boom, you get polyethylene, the solid plastic in a shopping bag, and it won't melt till it's way over 100 degrees C. Or how about this one? Glucose. It's just sugar, right? It dissolves in water instantly. But string those glucose monomers together, and you get a polysaccharide like cotton, which is, totally insoluble. The change is just massive. And this isn't just a fluke, it's a general rule. See, these long, tangled-up polymer chains are way stronger and harder to pull apart than the tiny little individual monomers they're made from. And that's why they have much higher melting points and don't dissolve as easily.
So, okay, how does this one simple idea build the entire world around us? Because when we hear polymer, a lot of us just think plastic, right? Something made in a lab. But that is only half the story.
So, what do you think? Is this all just human invention? Does this kind of molecular engineering only happen in some factory? Nope. False. Not even close. Nature was the OG master chemist here. It's been building incredibly complex polymers for literally billions of years, way before we showed up.
The truth is, we're surrounded by both kinds all the time. You've got natural polymers like silk or the cotton in your t-shirt, even your own hair. And then you have the synthetic stuff like that plastic bag, a nylon rope, or the PVC pipes hidden in your walls.
All right, let's pull all this together. Let's recap what we've learned about this world that's built from these simple repeating chains. Okay, pop quiz time. We know glucose is just sugar, and it dissolves in water, right? And we know cotton is just a super long chain of glucose. So, does your t-shirt dissolve when you throw it in the laundry? No, of course not. And that's the whole point. That's the core lesson here. The second you link those monomers together, you create a totally new thing with totally new rules and new properties. So let's sum it up. What are the big takeaways? 1. Polymers are giant molecules made from little repeating units called monomers. 2. The type of monomer you use, that determines everything. 3. Turning monomers into polymers causes huge, huge changes, like a gas becoming a solid. And 4. They are everywhere, both natural, like your hair, and synthetic, like plastic. So what does this all mean? It means the next time you grab a water bottle or put on a shirt or just, I don't know, run a hand through your hair, you'll know the secret. You're interacting with these amazing hidden chains. So seriously, just for a second, look around you right now. How many polymers can you spot?